Hey guys, either you are a working professional or you are searching a job, means you may be the students. You need to solve the DSA problems to crack any coding interview. Whenever you are going to solve the DSA problem, you will find out there are some patterns which is using for a certain problems. Today I'll be discussing about top 20 patterns for DSA problems. The first pattern is sliding window. Whenever we need to handle the input data for a particular window size, in that case we will use a sliding window technique. If we are talking about the DS which is involved for the sliding window, that is array, string and hash table. So there are few examples for sliding window technique like loops into a bucket. The second pattern is Iceland, which is matrix traversal. Whenever we need to traverse the matrix in the efficient way, we need to use this technique. Matrix and queue data structure is used for this technique. If we are talking about the example, if we need to find out number of islands, maybe flood field or cycle into a matrix, we will use this technique. Third pattern is two pointers. Two pointer techniques is used to iterate the input data. Generally, both pointers will be moving in the opposite direction. If we are talking about the DS involves in two pointers, which is array, a string or maybe linked list. If you talk about the examples of two pointers, squaring a sorted array, Dutch national flag problem, minimum window sort. So which will be using two pointers. Next technique is fast and slow pointer. It is used to traverse the input data in a different speed. It is also called hare and tortoise algorithm. So the data structure which is involved is array, string and linked list. If you are talking about the simple example, that is find out the middle of the linked list, find out the happy numbers or maybe cycle into a circular linked list. Next pattern is merge intervals. This pattern is used to deal with the overlapping intervals. The data structure which is involved for merge interval is array and heap. Simple example for merge intervals is conflicting appointments, find out the minimum meeting rooms. Next technique is cyclic sort. We use this technique to solve the array problems where the input will be given within the fixed range. Data structure involved in this is array. If you are talking about the simple example, that is find out the missing number or find out the duplicate numbers. The next pattern is in place traversal into a linked list. It is used to traverse the linked list in an efficient way. It will traverse within the linked list without using any extra space. Data structure involved into it is array. Simple example is rotate a linked list or reverse every kth element sublists. In this list, the next technique is BFS, breadth first search. This technique is used to solve the problem for traversing the trees and graphs in BFS manners. The data structure which is involved is tree, graph, matrix and queue. The simple example is binary tree, level order traversal, contact level order siblings, etc. The next one is DFS, depth first search. This technique is used to traverse tree or graph in a DFS manners. The data structure which is involved in DFS is the same as BFS like tree, graph, matrix, etc. If you talk about the simple example, so that is find out the path with given sequence, count the path for a particular sum, etc. The next one is two heaps. Suppose if we are given a set of elements that can be divided into two parts, and we need to find out the smallest element of the first part or maybe the largest element or biggest element of the second part. Min heap is used to find the smallest element and max heap is used to find the largest element. If you are talking about the DS involved, which is array and heap. If you are talking about the examples, find out the median of the number streams or find out the next intervals, etc. The next technique is subsets. Whenever we need to solve the problem for the permutations or combinations of a set of elements, we will use this technique. The DS involved is queue, array or strings. The simple example is, suppose we have to find out a string permutations by changing case or unique generalized abbreviations like. The next technique is binary search. So this technique is used to find out the element into a sorted array in efficient way. A DS involved is array. If you are talking about the simple problems, so which is scaling of numbers or find out the bitonic array maximum, like the next technique is bitwise XOR, XOR. This technique is used to perform the XOR operations to manipulate bits and solve the problems. The DS involved in this technique is array or bits. For example, find out the two single numbers like that, or flip and invert an image, etc. The next technique is top k elements. This technique is used to find out the top or smallest or frequently occurring k elements in a set. The DS involved in this technique is array, heap or queue. The simple example is find out the maximum distinct number, k closest point to the origin, etc. The next technique is k-way merge. K-way merge. This technique is used to solve the problem that involves a list of sorted arrays. The DS involved is array, queue and heap. The simple example like find out the kth smallest number in m sorted lists, or find out the kth smallest number in a matrix. The next technique is topological sort. When we need to find out the linear ordering of elements that have dependencies on each other, we will use this technique. The DS involved in this technique is array, hash table or queue. The simple example is task scheduling. The next technique is 0-1 knapsack. This technique is used to solve the optimization problems. So suppose if we need to select any elements that give us the maximum profit from a given set with a limitations on capacity, and each element can only be picked only once, we will use this technique. The DS involved in this technique is array and hash table. The simple example is find out the equal subset, some partition. Find out the minimum subset, some difference. The next technique is Fibonacci numbers. So this technique is used to solve the problems which is related to the Fibonacci numbers. So every subsequent number is calculated from the last few numbers. The DS involved in this is array and hash table. The simple examples of these types of problems is a staircase or house heap, etc. The next pattern is palindromic subsequence. This technique is used to solve the optimization problem of a palindromic subsequence or strings. The DS involved is array and hash table. For example, if we need to find out the longest palindrome subsequence, and the last pattern in this list is longest common substring. This technique is used to find out the optimal part of a string or set of strings or subsequences. The DS involved in this technique is array or hash table. The example of this technique is maximum sum increasing subsequence or added distance. So these are the top 20 patterns of DSA problems. If you like this video, please hit the like button. If you still didn't subscribe this channel, please subscribe it now. Thank you.